class, this is a video about colloids. I need you to pull out your notes. Where you need to make sure you fill in your notes. You need to be very careful about doing that. We're going to review just a little bit of vocabulary. So solutions are homogeneous mixtures, okay? And remember, if they're homogeneous, then they're miscible. Or is it miscible? Anyway, they're miscible. That means they do not separate. And it's not that one. It's that one. And suspensions then are okay. Oh, by the way, if they're miscible, they both have to be polar or not polar. Remember, polar things dissolve other polar things, or things with charges like ions. So that rule is like dissolves like. So non-polar things would dissolve other non-polar things. Like gas is not polar, so it's not dissolvable. Soluble is the right word, by water. So in order for it to be miscible, they both have to be the same thing. They have to be polar, both of them polar. Water would dissolve some other thing like alcohol, which is also polar. Now we have something called suspensions, which are not really solutions. So a solution is a homogeneous mixture. Things are miscible, like dissolves like. A suspension are mixtures that contain large particles or larger particles that eventually will settle out. Can you think of an example? Okay, I'm going to go to the Prezi. I think I have a couple of pictures of something that is suspension. Yeah, so here we go, suspensions. Before I look at that, let's just look at this picture on particle size. We have a true solution where you have tiny little particles inside the solvent. Okay. And notice particle size is less than 10 to the minus 7 centimeters. And then the colloid, the particles are slightly larger, and they're going to scatter light. Eventually, we'll be able to see that. And then a suspension has even larger particles. So a true solution is the smallest particle size, then a colloid, and then a suspension. And I really just want you to know that. I don't want you to necessarily memorize the particle sizes themselves, except for what's in your notes. So we're talking about suspensions next. And a common suspension is suspensions are mixtures where the insoluble particles are suspended, but they end up settling out eventually. So this is an example of a suspension. But this is the one I'm always thinking about: children's Tylenol. Notice that it says children's Tylenol, an oral suspension. So it's important for that, in that case, for you to mix it up really well, so that the medicine is dispersed through the liquid, and you don't end up giving your child more than they need. So that's just a common one. Now we'll come back to the video, to the Prezi for a moment after we go to our notes. So here's our notes. So one of the common example was children's Tylenol. Okay, so you can write that in this blank. Tylenol. All right, now what are colloids? Now remember, a suspension was the largest particles, and we're going to have another chart with it down here. Colloids are not solutions, and that's important. A solution is a homogeneous mixture that's miscible. A colloid is not a solution. Mixtures that contain small particles dispersed in a medium. So it's dispersed in a medium. The particles are sometimes called the dispersed phase. So the dispersed phase are the particles, the things you're dissolving. The medium is the dispersing medium. The dispersing medium is what we normally think of as the solvent, but it's not a solvent in this case because they're not dissolved. Fog is an example of a colloid. So what is the dispersed phase? What is dispersed inside something else? Well, in this case, water particles are dispersed. So water drops are dispersed inside what medium? Air. So we have a liquid, droplets dispersed in air. The dispersed phase particles usually exceed 1 nanometer, okay? And then remember, a nanometer is 10 to the minus 9 meters, okay? But cannot exceed 1,000 nanometers. So 1 nanometer and 1 nanometer is equal to 10 to the minus 9 meters. It's very, very small, but it cannot be bigger than 1,000 nanometers. And so I prefer that you think of it in this way. So let's look at these colloids, some examples. If the particle is a liquid and a gas is the medium, you have an aerosol, fog. There's fog. Okay, common names are aerosol, but examples are fog and clouds and mist. A solid and a gas, you'll have smoke. A gas and a liquid, you'll have a foam like shaving cream and whipped cream. A liquid and a liquid, you'll have mayonnaise. Oil dispersed in water. Solid and a liquid, you could have paint, pudding, blood, gelatin. All these are examples of colloids. A liquid and a solid, cheese and butter, these are all colloids. So pay attention to these colloids names. And extra credit, I'm going to ask you to name some of them. And I just want you to kind of get familiar with them so that if I ask you if fog's a colloid, you will know, yeah, that's in a colloid. Now here's the particle size, the difference between a solution where the particle has to be less than 1 nanometer, a colloid between 1 and 1,000 nanometers, and a suspension where it's greater than 1,000 nanometers. So that's what the particle size is right here. This is what I want you to be familiar with. Basically, the solution is the smallest, and greater than the solution is a colloid, and greater than the colloid is a suspension. And what we're talking about again is how big the particles are. Little, slightly larger, and larger. Okay? 1 nanometer, 1 to 1,000 is a colloid, and greater than 1,000 is a suspension. And that brings us to more properties of colloid. John Tyndall demonstrated in 1869 that particles in colloids are large enough to scatter light waves. This is where we get the Tyndall effect, okay? The Tyndall effect. The Tyndall effect is used to distinguish the difference between a colloid and a solution, partly because they sometimes look the same. They're both kind of clear liquids. If you send a beam of light through a solution, you won't be able to see where the light's going. So here we have an example of the Tyndall effect. Here's the light coming out of here. When it hits the colloid, you can see where the beam of light goes because the light's basically being scattered by the particles. The particles are big enough that the light waves are hitting it and bouncing off, and you can see it. But when the light goes through the solution, you can't see it. The particles are too small, and they're not scattering the light. That's the Tyndall effect. I can tell a true solution. This is a true solution right here because it does not scatter the light from a colloid because the colloid scatters the light. That's the only thing you really have to know about that, and that's the end of the notes. So let's go back to the video, to the Prezi, and I give you another example. This one's just a little more clear. Though this is the one before that is the one you have in your notes. Whoops, too far. So that one right there, that's the one you have in your notes, but there's another example I think that's just better. It's clearer picture. Again, see here, we're sending light. Now notice that this side, it's clear all the way through. So this one is the true solution. This side scatters the light so you can see the light beam going through the liquid, and that's the colloid. Now they almost look the same. This one's a little cloudy, so that might make you think that it's not a true solution because a true solution won't be so cloudy. All right, so that's the end of your notes. Don't forget, you need to spend time in the Quizlet. And so I'm going to make sure I look at it, make sure it's ready for you so you can go through the vocabulary. But it is very important you spend time in the Quizlet. And then here's a bunch of videos for review about what happens when stuff dissolves and some other places where you can go for simulations. So spend some time in those simulations as well. All right, so that's the end of our notes, and I will see you soon.